Okay, so when there is two people and they're trying to shoot a dart toward the target, one is higher than the other one is a lot smaller, then you can say it is important to consider the acceleration due to gravity. While the dart is thrown, there is a vertical velocity component and horizontal velocity component, as they are both standing at the same distance away from the target. They should aim higher than the target, considering gravity will pull it down and have an effect. Little John is much taller, so he would not have to angle the arrow up as much as Robin Hood because it's starting from a higher point. So when we look at y direction, it has constant acceleration. We have to calculate the change in time to hit the ground. v1 equals 0. Acceleration equals gravity. Change in dy is different, and change in t is different. When it comes to x direction, it has a constant velocity. We have to calculate change in d, which is change in direction, the range. V is the same. Change in t is different, and change in dx is different. So this is like when something's like falling onto the ground. So the higher projectile will have a larger range because it will take longer to hit the ground, because it starts higher up and has the same acceleration. And in that time, it will cover more horizontal distance because it will be moving at the same horizontal velocity for a longer time interval than the lower projectile. And then remember that the equation for solving time is, so remember VPS and then arrow. The first letter is what's moving, and the second letter is what it's relative to, right? So P, passenger, relative to the ship that is not moving. And so it would be V, remember the arrow, equals delta T over delta T. And then solve it.